Hello dear students, good afternoon to everyone. So I welcome you to NEET World. So today we will be discussing haloalkanes and haloarenes chapter here. So based on the previous year topics which we have discussed, GOC and the next hydrocarbons we have covered. So after that we will be starting haloalkanes. This will be the first organic chemistry chapter in class 12th, right? Okay. So here what we will be going to discuss here. So completely regarding haloalkanes and haloarenes, including the previous year questions. Okay. So let us start our discussion. So first thing is let us classify halogen compounds like organic compounds which are containing halogen atoms can be considered to be halogen compounds here. So here based on the number of halogen atoms present in a given compound, it will be like if it is only one halogen atom, it will be monohalogen. If it is having two, it is di. If it is three, trihalo compound. Then next like that. So we can say polyhalogens like this. Okay. Similarly, when it comes to hybridization of carbon which is attached to the halogen atom. For example, here we know, see, halogen atom, let us indicate with the symbol X. X represent what? Halogen atom. Okay. So this, if it is attached to the carbon, so this carbon, if it is sp3 carbon, so we have one set of classification. If it is having sp2 hybridization, we will be having another set of classification. So then let us discuss about sp3 hybridized carbon. When carbon attached with the halogen, what I am saying, the sp3 hybridized carbon attached to the halogen. So we have this type of classifications. What is that? Alkyl halides. Okay, for example, methyl halide is there. So in this methyl halide, so here X means it can be chlorine, fluorine, bromine, iodine, anything. Okay. So here if this is the halogen, so this carbon is what now? sp3 hybridized carbon, right? So that is what? sp3 hybridized carbon. So if this is sp3 hybridized carbon, we can say alkyl halides. So this example is called as methyl halide. If it is ethyl group, ethyl halide. So like that we can generalize them as alkyl halides, right? Okay. Next, allylic halides. So what do we mean by, see, it is very important to understand these terms: allylic halides, benzylic halides, and the next vinyl halides and aryl halides. So based on these terms only there are many questions we can see in the exam also. So I will show you what exactly allylic, benzylic halides here. See, the carbon, like halogen atom, let us say chlorine atom will take. So this should be attached to a sp3 hybridized carbon like this. So this carbon is what now? I am saying it is sp3 hybridized carbon. Okay. So what I am saying here, carbon is sp3 hybridized carbon. So this should be attached to any other group. For example, here, so valence is satisfied to this carbon with sp3 hybridization. Now this carbon is attached to a conjugative position, like conjugative system. Like see, here we have one double bond now. So this double bond, see, if I remove this chlorine like this, so we will be getting a stable carbocation, that is what? CH2 CH CH2. See, this kind of carbocation we are getting now. So this species is called allylic chloride. So allyl chloride, this is called allyl carbocation. What is it? Allyl carbocation, which is stabilized by this conjugation like this. So it will be stabilized by conjugation. Again students, I am saying that since we have in very short time we will be having exams now for NEET and JEE EAPCET. So for that I will be focusing mostly on the important topics that must be covered for the upcoming exam. So that session will be more helpful for those aspiring students, right? Okay. So this kind, see, allylic stabilization is taking place when we have this pi electrons are at conjugative position with this like carbocation. This conjugation is possible and the system is called allylic carbocation. Okay. See, in allylic carbocation, allylic halides, see, halides should be attached to the what? Halides should be attached to the carbon which is what? Which is sp3 hybridized. I hope it is clear. Okay. Next, what about benzylic? So when I am saying benzylic, so take one phenyl ring, that is what the benzene ring you can take like this. Okay. So here I am removing one hydrogen and I am replacing with one alkyl group like this. Okay. So this carbon this carbon position is called what? Benzyl position. So on the phenyl ring, the carbon directly attached is called benzyl carbon, and that position is what? Benzylic position. If to that carbon any halogen is attached, so we can say benzyl halide. If it is chlorine, benzyl chloride, like that we should call. Okay, so what is the hybridization of this carbon? Here it is also sp3. Okay, now just remove this halogen from here, like X minus, because of its electronegativity, polarity takes place, therefore it generates a carbocation like this. So this is called what? Benzylic carbocation. What is that? This is what? Benzylic carbocation, and this is allylic carbocation. So both of these are stabilized by resonance. I explained what exactly resonance, hyperconjugation, inductive effect, mesomeric effect, everything. So based on that we can explain here. So mesomeric effect possibility is there now. So by shift of these pi electrons into the carbocation vacant orbital, p orbital of this carbon, stabilization takes place, right? So because of that reason, allylic carbocation and benzylic carbocations are highly stable. So these applications are there in our upcoming slides. We will be seeing with their previous year questions. Okay, next. So as I like alicyclic halides. So generally, if any like ring is there, cyclic ring is there. So on that, if any halogen is attached, so this carbon is what? sp3 hybridized. That's it, alicyclic halides. Okay, so this is simple classification based on their hybridization of sp3. Here we have sp2 hybridization. Here you need to know what exactly vinyl and aryl. So when I am saying vinyl, so the carbon here is sp2 hybridized. The carbon which is attached to the halogen is what? sp2 hybridized. See, this is the halogen I am saying. This is directly attached to a carbon which is sp2 hybridized. Okay, halogen attached to the sp2 hybridized carbon is called vinylic halides or vinylic position carbon. This is okay. Now if we see the vinylic halides, these are stable. What I am saying, these are stable because of like involvement of lone pair electrons with conjugation with this pi electron. See, this lone pair electron, non-bonding electron of halogen can involving the conjugation with this pi electrons. How this conjugation takes place? Look here. See, here I am writing once again. So this is the halogen where it contains non-bonding electrons like this. It may be chlorine or any halogen you can consider like this. Conjugation takes place now. Therefore, I can say this is what? Stable alkyl halide. I mean, because of their conjugation like this. Because of their conjugation. See, when it is giving this lone pair electrons, non-bonding electrons, the here partial double bond character is created, here positive charge, and these pi electrons are shifting over here negative. Yeah, so this kind of stabilization takes place in vinylic halides. Okay, so due to the these are very labile. I mean, I can say labile and inert. So I can say this is very inert compound. What I am saying, inert. Inert means it will not show reactions. Why it will not show reactions? Because the lone pair electrons and halogen is involving in the conjugation. So whereas in case of allylic position, it will be easily removed out. Therefore, the resulting carbocation is stabilized by the conjugation. So I can say this is labile. Labile, it means what do we mean by labile halogens here, labile halogen compounds here. So they show or they involve in the chemical reactions easily, but I am saying this is inert compound. Why I am saying inert? So because it is stabilized by the conjugation of this halogen electrons with the pi electrons of this like pi electrons of this alkene. So therefore I can say this will be inert to the chemical reaction. They won't participate in chemical reactions again. So the resulting carbocation, if I remove this halogen from here, will be like this vinylic carbocation, which is highly unstable. So vinylic carbocation is highly unstable. I hope it is clear what exactly vinyl means. So what exactly vinyl? Halogen attached sp2 carbon is called vinylic carbon. The compound is vinylic halide. Similar to that, we will be having, see, this will be phenyl ring, okay, or benzene ring, or we can say simply aryl ring. So to this, if directly halogen is attached, so we should say aryl halides. or haloarenes. So here also these lone pair electrons are in conjugation with this pi electrons of the ring. Therefore, this also shows inertness to the chemical reaction. They won't participate in chemical reaction. That's why we are saying vinyl halides and aryl halides will not show substitution reactions. Nucleophilic substitution reactions will not take place in vinyl and aryl halides. It will be possible in allylic benzylic halides. I hope it is clear because these statements are very important to understand the upcoming chemical reactions. I will show you why these points are important also. See, due to the lone pair electrons participation in conjugation with the pi electrons, it will be having some partial double bond character, or the bond strength will be increased here. Okay, due to that reason what happens, it will be having inertness towards the substitution reactions. Okay, I hope it is clear. In vinyl halides, aryl halides, the carbon attached, the halogen attached carbon is what? It will be having sp2 hybridization, whereas allylic benzylic carbons will be having sp3 hybridization. This is the points you should remember. Okay, now identify here the given compound, yes, is an example of what? Yeah, so identify whether it is vinylic, allylic or benzylic. Yes, look here, so this is a benzene ring. Okay, if it is attached with this carbon, we should say it as benzylic halide, but the halogen is attached to a sp3 hybridized carbon. Yes, that sp3 hybridized carbon is in attaching with this sp2, like double bond sp2 carbon hybridization. It means what position is this? So identify this system. Just now we discussed about this. See, here we discussed. See, what do we mean by allylic halides here? So allylic means what? The halides will be attached to a carbon which is in conjugation with this like pi bond, I mean sp2 hybridized carbons. Yes, so this is the same story here we need to understand. See, double bonded carbons are attached to sp3 hybridized carbon where we have one halogen. So why I can say that is allylic halide. Yes, I hope it is clear. So which option is correct? Allylic halide. Next, which one of the following an example of allylic halide? Yes, so how can we identify this? See, I don't want to waste discussing too much time on theory, so I will be discussing the theory plus concept plus PYQs using the previous year questions of NEET and EAPCET, because we need to feel that every student should feel that, so you are solving the previous year questions also. Okay, now it's time for solving or focusing more on PYQs instead of only on theory. Yes, we need to cover theory, but PYQs are much important here. Okay, it will give us some clarity and confidence. So what we need to focus, right? Okay, so example of allylic halides here. Yes, so write the structures first. It is very simple. So butene you write first, but 1 ene, let us say here 1 ene. Okay, 4 chloro. So 1, 2, 3, 4. If I say this is a 4 chloro. So did I told you this is vinylic or allylic position? See, this carbon is attached to the sp3 hybridized carbon. This chlorine is attached to the sp3, but this should be attached to what? It should be attached to one sp2, like double bonded carbons. But it is not like that. It is attached to the sp3 hybridized carbon only. So this is not allylic or not even benzylic or not even vinylic or any other thing. So it is just a sp3 hybridized carbon chain. Okay, next here just go for this option, but 2 ene. Yes. Next 1 chloro but 2 ene. So if I say numbering from here, yes, we are almost at our answer. Yeah, see, this is sp3 hybridized carbon attached to one sp2 like sp2, I mean to one alkene group. So I can say this position is what? Allylic position only, na? Yes, so this is an example of allylic halide. So you can go with this option. Okay, so you can try for option C also. So just draw that. I hope you got the difference between what exactly allylic and vinylic and normal halogen compounds, right? So go for option number 3 once again. So but means 4 carbons, 1 ene, yes, you can insert here, and next 2 methyl, yes, you can insert one methyl group here, and 3 chloro. yeah, 3 chloro, yeah. So this is also allylic, yeah. So 3 chloro, this is also allylic. So what he is asking, not an example he is asking. Yes, this is not an example of allylic. Yes, this is an example of allylic. So this is also what? Example of allylic only. See, if we remove it like this, see what I told you, allylic carbocation is generating there. See, look here, this is what? sp3 hybridized carbon, so which is attached to the double bond. Yes, so it means it is having some conjugation, right? I mean, if I remove this, then the conjugation will be taking place for the carbocation stability. Yes, so I can say the system is what? Allylic system only. So allylic halide, this is also correct. Next, this is also allylic I am saying. So what he is asking, not an example he is asking. Go for this. Yes, next. Pent means 5. Next, second position double bond. Yes, then next 1, 2, 3, 4th. Fourth position what? Chlorine. Yes, this is also what? See, sp3 hybridized carbon attached to the double bonded carbons. It means this is also allylic position only, no? So this is also allylic positioned carbon, I mean allylic halide only. So these 3 are allylic halides. What is he is asking? Not an example. Yes, so this is not an example. So you have to choose, not he is asking now. So you have to choose the first option for this particular question in the exam. I hope it is clear. So for B, C, D are having allylic position, allylic halides, but A is not having allylic halides. So you can go with the option 1 here. I hope it is clear, right? Okay. Next, so those are the simple basic questions we have. Next we have here preparation methods of alkyl halides. Yeah, so once we, after discussing some basic concepts here, we'll again solve the questions. So from alkanes, how can we prepare? Yes, in the last class, it means from hydrocarbon chapter only, I have discussed free radical substitution reaction mechanism, where alkanes, like you can take some alkanes. For example, here we have started basically with methane, where we have chlorinated using some sunlight, right? So if we are taking this in the excess amount, if we are taking this in the excess amount, we will be getting CCl4 as the major product, polyhalogenated product. If you are taking methane as a major and Cl2 as a limited amount, if this is excess, so we will be getting major product as methyl chloride. All these things we have discussed in the hydrocarbon chapter. Fine, no issues. Again here you can look, there I also explained. So questions will be like this. So they will give some hydrocarbon chain like this. Okay, so now you can do chlorination for this, and they will ask how many types of products are possible for this particular reaction, they will ask. Okay, so for complete explanation you can see hydrocarbon lecture there. Okay, for alkanes you can see hydrocarbons lecture number 1 in the playlist. You will be getting complete idea on this. So if you want, I will give some clarity with some tricks here. So they will give one question like this, and they will ask us what are the number of possible products here. So in that case, what you need to do is just highlight the hydrogen atoms present here. How many types of hydrogen atoms are present here? Check that. Yes, so the terminal carbons are same, therefore hydrogen present on these terminal carbons are same. Okay, it means even if I replace one of this hydrogen from here or here, we will be getting one kind of product that will be like this. The monohalogenated product will be like this. Yes, this one is 1. Okay, now I can do monohalogenation similarly at this hydrogen. See, this internal hydrogens, these 2 methylene groups are also same. If I replace one of that hydrogen, we will be getting this kind of product. Yeah, so these are the 2 types of products we can expect, right? Okay, now out of these, yeah, is there any chiral carbon generated? What do we mean by chiral carbon? See, here to this carbon, one side methyl, another side is ethyl group is attached, one is chlorine and other one is hydrogen, right? Okay, so now if they ask total number of possible products for this reaction, if they ask, so if there is any chiral carbon is generated, then you can say there will be 2 types of product in this. So you can use 2 power 1. So what is this 2 power n formula represents here? N represents number of chiral carbons present in the given compound. So how many chiral carbons are there? It means chiral means what? four different groups around the carbon center should be there, then we can say this is chiral center. Okay, so here 2 power 1, it means it will be giving 2 products. Okay, in this case, in one product it will be chlorine will be above the plane, other one chlorine will be below the plane, therefore 2 types of products will be obtained here. So I am writing 2, and this is, there is no chiral center, so this is optically inactive, therefore this will be 1. So total 1 plus 3, 1 plus 2, so total 3 products will be obtained. You should say like this. I hope it is clear. Okay, now they will be asking one more question. Out of these 2, which is major product and which is minor product? So they will ask like this also. And how can we identify, so what is the percentage of major and also what is the percentage of minor? So this kind of questions also they may ask. Okay, all these things we have discussed there in the hydrocarbon chapter. I hope you have seen that lecture. If not, you can go and watch that, so you will get some clarity, like how much product of this A and how much product of this B product is formed, which is major, which is minor, everything you can calculate using that trick. Okay, next. So here again, here again one more thing. So from alkenes, if we talk from alkenes, so from alkenes also, this is also we discussed there. From alkenes if we talk, so let us say this alkene we have, so we can do 2 types of addition here. So let us say addition of HBr, electrophilic addition reactions takes place now, HBr. So simply HBr will be giving by following Markovnikov rule addition. So it will be first add this H plus and generate a carbocation, stable carbocation. Therefore here the stable carbocation is generated. There you add Br. Okay, out of this H plus Br minus, first you add this H plus to this double bond, therefore so this carbon will be getting this hydrogen, and on this carbon you will be adding Br minus. Okay, I hope it is clear. This is what Markovnikov rule addition. So everything is clearly discussed in the hydrocarbons chapter there itself. So here I just giving some revision and where questions will be asked on this, so that I have kept this here also. Okay, next, same HBr is there here, but here it is having some peracid, like peroxide, some peroxide bond is present in the given compound. So in this case you will be getting this as a major, this as a like opposite of this. So this will be the major and this will be the minor product in this case. So I hope it is clear. So here it is major, this is major and this is minor. So in this will be the major and this will be the minor. This will be the minor. So it is Markovnikov addition, this is anti-Markovnikov addition products. Okay, I hope this is clear. Next, we can also add chlorine directly, chlorine or halogen X2 type in CCl4, non-polar solvent. Therefore we will be getting what? So we will be getting like dihalogen compounds like this. So on double bond you add one chlorine at one position, other chlorine at another position, like on one more site. Okay, this is what halogenation. This is what hydrohalogenation we can say. Okay, now one more thing, see this one when it is treated with chlorine in presence of sunlight or high temperatures, what happens is, see this position, this methyl group is there, this position is called allylic position, where chlorination takes place by following free radical substitution reaction mechanism. So just you have to write it like this and put one chlorine over here. So this is what happened, FSR, free radical substitution reaction mechanism. So same thing also happens with the NBS, N-bromosuccinamide in non-polar solvent. Okay, so what happens here? So just NBS, now N-bromosuccinamide I am saying now. So it will be releasing bromine radical that will be added on this free radical site, I mean this allylic position. So it is what? At allylic position bromination takes place. So I can say NBS is a allylic brominating agent. Similarly allylic and also story applicable for benzylic position also. Okay, so allylic benzylic brominating agent, this NBS is. Next, When it comes to alkynes, you just remove this double like pi bonds and add this halogens 2 times, we will be getting this one. Okay, if we want to add HX, first add 1 mole of HX, therefore addition of H should be here and X should be here. Similarly, second step also follows same thing, H here and X here, therefore we will be getting R CX X and this is CH3, that is what the product here is. Yeah, this is again very important. This thing we haven't discussed in the last class. Listen here, very important topics these are. Okay, so from what we are preparation of alkyl halides from different compounds. First case it is from alkanes, next from alkenes, next from alkynes, and now it is from alcohols. So here I have ROH, which is alcohol. So when we treat this with acids, halogen acids like HX, HX means HCl, HBr, HI. Okay, so now tell me what is the acidic nature of HX, I mean HF, HCl, HBr and HI if I ask. Yeah, so what is the acidic nature order? What I am asking? Acidic nature. So always remember HI is stronger acid than HBr, then HCl. Yeah, this is also important point. Okay, now let us say here I have HBr. In the first case what I am taking? HBr. So let me take that reaction separately here. So ROH plus HBr I am taking. See, I told you HBr is acid, strong acid. It releases H plus ions. Okay, so that will be abstracted by this lone pair electrons of oxygen and forming what? ROH2 like this, plus therefore water will be removed. So it will be removed like this. So what we are getting on this carbon of the alkyl group carbon, we are getting a positive charge where this Br minus will go and attack, finally gives us RBr product, RBr. So for example here I am writing here methyl alcohol. To this I am adding HBr. So what happens, tell me? See, this H plus, this OH minus is removed, therefore what is the remaining thing we have? CH3Br. So this will be the final product. So this is what you need to understand here. I hope it is clear. Okay, now let us go with some bigger examples. Yeah, now here I just mentioned it as HX now. Okay, so what? There are some other species also, we will be discussing about them also. See, for example here I am taking like this. Yes, okay, so here I mentioned like this. Okay, so this is what? Alcohol only. Okay, now I am reacting this species to this substrate. I am adding concentrated HCl in presence of anhydrous AlCl2, ZnCl2, anhydrous ZnCl2. So this particular species, this one is what? This is called Lucas reagent. What is this? This is called as Lucas test or Lucas reagent. So what is the formula of Lucas reagent? Concentrated HCl, anhydrous ZnCl2. Okay, so this is you need to remember here. Okay, so now when it is reacting with this particular substrate, what happens? HCl, H plus ion is released here and OH, therefore elimination of water takes place and it will be generating something called carbocation. See, I am explaining the mechanism here. So add this, therefore together it will be becoming OH. See, already OH is there. To this we are adding H plus. Okay, it means on oxygen we are getting a positive. Here it is having positive charge. Now elimination of water takes place like this. So what we are getting here? It is a carbocation. No? So this carbocation is secondary carbocation. What is that? Secondary carbocation. So to this, if shift this to here, what happens? We will be getting a tertiary carbocation. On this you can add chlorine, chloride ion, negative part. So we will be getting Cl like this. I hope it is clear. So this is what happens with HX. Okay. Now they will ask us what is the reactivity. For example, sometimes we will be having see here I am writing a straight chain. Okay, so how many carbons are there here? So we have see 4 carbons are there. So but this is primary alcohol. Here we have same molecular formula here also. Here also same molecular formula. So with 4 carbons, but this is secondary alcohol. So how I am saying for primary secondary alcohols here. So if OH group is attached to the carbon which is attached with only one carbon atom directly, then we can say that is primary. If the carbon is attached with the 2 other carbons directly, so we can say that is secondary alcohol. If the OH group is attached to a carbon where it is attached to the other 3 carbons directly like this, so we can say this is tertiary. Okay, so out of these 3, which will be reacts readily with the Lucas reagent? If they ask, you should always go with 3. So 3 degree, more than 2 degree, more than 1 degree alcohols. See, this is the order I have mentioned. See, in the exam they will give, so which of the following gives turbidity within the seconds? Yes, so when we treat with Lucas reagent, tertiary alcohol will be producing turbidity within the seconds, like within some 5 to 8 seconds we will be getting turbidity. It means this is what the most reactive towards the Lucas reagent. So you can say 3 degree, 2 degree, 1 degree. Okay, I hope it is clear. Okay, next we have, yeah, so here a few more reactions are also mentioned here. PX3. So here you can remember this reaction also. See, whenever we will be having a species like this, see here I am mentioning its stereochemistry also, OH group. Okay, so see OH is an above the plane, no? So otherwise you can keep this in the below the plane also. Okay, right. This is also alcohol. So when we are treating with PCl3 or PCl5, what happens is this OH group will be reacting with this PCl5, and finally one of this chlorine from PCl3, or if we treat with PCl5, will be replacing or will be substituted in this position of OH. Therefore we will be getting a compound like this. See, the above the, like OH group is on the above the plane of this ring, right? So here it will be below the plane. It means inversion of configuration taking place. If it is R here, the configuration here it will become S. I hope it is clear. So wherever, sorry, here it should be chlorine. Yeah. So wherever OH group is present on that carbon, the configuration is above the plane. OH is above the plane. Here it will become below the plane, like Cl. So Cl will be into the below the plane. Okay. Now tell me, if I write a carbon like R, H, D, yeah, here I am mentioning OH above the plane, here it will be below the plane. Now tell me, when I am treating with PCl5, so what is the product formed here? So you just write these things as it is. Okay, here this whatever the OH group which we have mentioned above the plane, like this like wedge dash notation here, above the plane we represented na, so that will becoming below the plane, and it will be Cl here. I hope it is clear, and D will be above the plane here. Configuration is reversed here, no? So this is what happens, inversion of configuration takes place, and the byproduct formed here is POCl3. What I am saying, POCl3 is a byproduct formed here, and here 1 mole of these can react with 3 moles of alcohols and will be having H3PO3 as a byproduct. Okay, I hope it is clear. Okay, next, what is the mechanism I told you in this PCl3 PCl5 case? It is SN2 mechanism. It means inversion of configuration takes place. If it is having above the plane, product will be having below the plane configuration. I hope it is clear. Next, when it comes to thionyl chloride, thionyl bromide here. Okay, so this is one of the best method for preparation of halides respective alcohols, because the gases produced here is easily removed, therefore product formed is easily separated from their byproducts. Okay, so what I am saying, if we have ROH, okay, let us take the same example here. OH we have like this above the plane. So when we are treating this with SOCl2, okay, configuration will be remains same. So here configuration will be remains same. So you can write chlorine as it is. Okay, just remove OH and replace with Cl. So this is what intramolecular nucleophilic substitution reaction mechanism in taking place here. So I am not explaining the mechanism, just remember the reactions and stereochemistry as it is. Okay. Now here what if we use SOCl2, but along with the SOCl2 what I am doing is taking pyridine, SOCl2 pyridine. So here when we are using pyridine, configuration becomes opposite. Simply when we use SOCl2, configuration remains same, but when we are taking pyridine along with this SOCl2 thionyl chloride, if we take pyridine, the configuration becomes opposite. Means it is above the plane, now it will be below the plane chlorine. Like this you have to write. Okay. So when it is happening, when we are taking pyridine as a base. Okay, I hope it is clear. Okay. What are the byproducts formed in the both of these cases? It is SO2 which is a gas, and HCl also gas, which can be easily removed out. Okay, this is the best method for preparation of alkyl halides from alcohols. Okay, next Fink-Liston reaction. So what exactly Fink-Liston reaction is? For preparation of alkyl iodides, see, iodination of alkanes is not feasible because of its reversibility. Therefore, we will be converting alkyl chlorides, alkyl bromides, alkyl chlorides, alkyl bromides to alkyl iodides. Okay, this reaction is what? Fink-Liston reaction. Here we will be using something like NaI, like this. Sodium iodide when treated with this alkyl chlorides, alkyl bromides when treated with sodium iodide, so it will be generating alkyl iodides. I hope it is clear. Fink-Liston reaction is for preparation of alkyl iodides. Remember this single statement, it's enough. Okay. Next, Schwartz reaction. So here also we will be specifically using this alkyl chlorides, alkyl bromides for conversion of alkyl fluorides. So Schwartz reaction is for preparation of alkyl fluorides. Okay, so alkyl fluorides are prepared by Schwartz reaction, where we will be using alkyl chlorides, bromides, iodides when we treat with some fluorinating agents like AgF2 or AgF, like this. So it will be generating like alkyl fluoride. So these reactions are what? Halogen exchange reaction. So what do we mean by halogen exchange reactions? Here see, already the substrate contains halogen, but that is exchanged. See, chlorine is removed and exchanged by this iodine. Yeah, chlorine is removed and replaced by iodine. So here it is chlorine, bromine is removed and replaced by this fluorine. So this is what halogen is exchanging now. So these reactions are halogen exchange reaction. Yes, once again remember, Fink-Liston for alkyl iodides, Schwartz for alkyl fluorides, that's it. Yeah. So now what we have studied? Free radical halogenation of alkanes generates what? Alkyl iodides. Next, when we take alkanes, so just go through this. Yeah, alkenes, when we take alkenes, so addition of X2 generates what? Alkyl iodides. Yes, but we have discussed about next addition of HX, that is what we discussed about Markovnikov rule, anti-Markovnikov rule, right? Next, alkyl iodides like halogen exchange reactions. Fink-Liston for alkyl iodides, Schwartz reaction for alkyl fluorides. Yes, discussed. Next, one more thing we have here, when carbonyl compounds are there, for example RCO, R is there. So when we are treating this with PCl5, so just we know in PCl5 it will be having trigonal bipyramidal geometry where two chlorines are axial and remaining three are equatorial, right? So that two axial chlorines will be replacing this oxygen. So just remember, remove two chlorines from here and place here one like this. So remove oxygen and replace it with two chlorine atoms. Next, we have one, see, out of these 5 chlorines we have utilized 2 now, so remaining 3 are there and 1 oxygen. So byproduct is POCl3, like this you can remember. So from carbonyl compounds we can prepare 1,1 dihalides or geminal halides we can say. Okay, then next this thing also we use in we have discussed in PCl3 or PX5 follows SN2 mechanism I told you, and the next S-thionyl chloride also best method for preparation of alkyl halides from alcohols. These things we discussed, right? Okay, next let us move forward. Okay, so nature of CX bond. Yes, nature of, what is the nature of CX bond? See, CH3X, if I say, see, halogens will be having relatively more electronegativity, therefore they will be having partial negative and carbon will be having partial positive, therefore they will show some polarity in their bond, right? Okay, so now when we are talking about dipole moment, what I am saying, when we are talking about dipole moment, mu is calculated with charge into distance, na? Okay, so now see, distance, the bond length is increasing, okay, and bond polarity is also changing from fluorine to chlorine, chlorine to bromine, bromine to iodine because of their electronegativity difference, right? Okay, so by considering both charge and this bond length, distance, we will be having bond length dipole moments like this. So the dipole moment for methyl chloride CH3Cl is more, yes, see, more than this methyl fluoride, which is more than methyl fluoride. Okay, then next see, this is what happening from here to here, you can check, and this is more than methyl bromide, then next methyl iodide. So this order is very, very important. See, methyl chloride is having 1.8, this is having 1.86, then next this is 1.84, and then next 1.83, and next 1.6. Okay, you can remember these approximate values at least are this order for your exam purpose. Yeah. Next, reactions of alkyl halides. So what are the reactions it will be showing? So alkyl halides, see, so we can convert alkyl halides to, see, there are some coupling reactions where we have studied about Wood's reaction. For example, what is a Wood's reaction? So when we take 2 moles of alkyl iodides, alkyl halides, when we treat with this sodium metal in dry ether, so what happens? Like coupling takes place and producing RR kind of product. Now, if it is methyl chloride or methyl halide, the product will be ethane. If it is ethyl halide, product will be butane. Like that, coupling reaction takes place in the Wood's coupling reaction, right? I hope it is clear. Next, when alkyl halides treated with this Grignard reagent, what is the formula of Grignard reagent? RMGX means alkyl alkyl group magnesium halogen. So just adding this R and this R will be producing like this. So let us take one example to avoid all these confusions or to get more clarity. So I am taking methyl chloride. Okay, to this I am adding sodium in dry ether. So what is the product formed here? This will be methane, methyl gives ethane. Yes. Next, to this I am adding some ethyl magnesium bromide. So C2H5MgX. So what is this? Ethyl magnesium bromide, which is an example for RMGX, will be giving us methyl. Yes. Why it is giving? See, this is having negative charge and this is having positive, this is having partial negative. Therefore, this will be attacks over there and will be generating CH2CH3. So propane is obtained in this reaction. I hope it is clear. Okay. Next, next is Corey-Howe synthesis. So in Corey-Howe synthesis, I told you we will be using Gilman's reagent. What is Gilman's reagent there? So alkyl, dialkyl, lithium cuprate, like this now. So this alkyl group will be added to our alkyl group of this alkyl halogen. So we will be getting R. Yeah. So mostly it will be alkanes products. Okay. So these 3 things we have discussed. Next, when alkyl halide, yes, when alkyl halide, see, I have brought all the reaction to discuss here itself. Just have a quick look into the reaction. Therefore, we can solve the questions easily and effectively. Okay. So like a revision session you can consider. See, when Rx is treated with ammonia, so what happens? Ammonia is having lone pair electrons now. See, halogen having more electronegativity, it will be taking the sigma bonded electrons towards itself. If this alkyl group is some methyl group, let us understand, methyl group or some ethyl group. So what happens here is, so these will be attacks on this carbon and this halogen goes out. We will be getting CH3, CH2, NH2. Primary amine is produced here. Okay. Now primary amine is having more reactivity than this ammonia. So whenever we are taking excess of alkyl halides, so we will be getting quaternary ammonium compounds, because this will be more reactive than this. Therefore, instead of involving this in the reaction, this will be involving in the further reactions and giving quaternary ammonium salts. I hope it is clear. Okay. Next, alkyl halide when reacted with this alkyl halides, when reacted with this KCN, yes, this is also important. So KCN, see K plus Cn minus, right? So now here this is ionic compound. So whenever chlorine goes out, this cyanide will attacks here and forms RCN. Okay, so alkyl nitriles we can say. Then next, when it is reacting with AgCN, see I am saying this is ionic. So in case of ionic, this kind of product is obtained. So when it is AgCN, it is having covalent nature. Okay, here in the last case, in the previous case, here carbon of this cyanide is forming a bond with this alkyl group. But here, since it is having covalent nature, so this bond will not be cleaved easily. Therefore, these electrons will donated to this carbon atom and forming isocyanides. So here it is cyanides, here we are getting isocyanides as the product. So when it is having covalent nucleophile, so isocyanates products. When it is ionic, cyanides are the products. Yes, this is important. Next, with the Grignard reagent already we discussed. Okay. Next, here also apply same story. So out of this NaNO2 and AgNO2, what we know here, Rx when treated with NaNO2. See, NO2 structure, can we write it like this? NO minus Na plus, like this we can write na. So now if this minus is given here when halogen is going out, so we are getting ONO2 like this, ONO. So this is what we are getting. So when we are taking NaNO2, this is ionic, so this will be the product. Okay. So when we are taking the same reaction Rx with AgNO2, and product will be different, AgNO2. So here this is having covalent bond, so therefore this bond will not be cleavage, it will not cleave, therefore this nitrogen lone pair electrons are donated here and forming RNO2. So these are the different products formed. You should remember this, or you should understand this. Okay. Next, when we treat alkyl halides with lithium aluminium hydride, we know lithium aluminium hydride, sodium borohydride, these are strong like reducing agents now. So even lithium aluminium hydride is stronger reducing agent. Okay. So whenever in the chemical reactions it is involving, it is act as a source of hydride ion, like it will be donating hydride ion like H minus. So H minus is the nucleophile. So when X goes out, halide ion goes out, H minus comes in as an incoming nucleophile, forms respective alkane. So if it is methyl halide, we will be getting methane as a product. If it is ethyl halide, we will be getting ethane as a product when we are using lithium aluminium hydride. I hope it is clear. Okay. Next, Williamson ether synthesis. Yes. So this will again study in the alcohols, phenols, ethers chapter. So what exactly it is? Rx when treated with some alkoxide ion, for example, so like this. So let us say this is alkoxide ion, this is Rx, alkyl halide. So it follows SN2 reaction mechanism. Just remove this halogen and substitute with this alkoxide group. So we will be getting ROR, which are ethers. So this is what Williamson ether synthesis follows SN2 mechanism. Okay. So soon we will be having a special discussion on SN1, SN2 mechanism very clearly, because so mostly we can discuss here also, but I want to discuss with a very long and very with a very detailed explanation of SN to SN1, because most of the students are having confusion in that. Anyways, so just remember that Williamson ether synthesis follows SN2 reaction mechanism like this. So what happens? Let us see one example like this. Yes. Then next, O minus, yeah, Na plus, yeah. So tell me, what is the product formed here? So when this nucleophile Cl minus, the leaving group, is going out, okay, when going out, this leaving group going out, so what happens is this carbon is getting partial positive character, right? So on that electron deficient carbon, the negatively charged oxygen atom will be donating its electrons like this. So I can say this is incoming nucleophile, okay. So this takes place simultaneously in the SN2 reaction mechanism, and they will be forming a transition state like this, chlorine, OET, I am right. OET means ethoxide ion, okay, like this it will be forming. Here the hybridization for this central carbon is sp2. What is that? sp2 hybridized. Now the chlorine goes out and it will be forms the bond effectively like this, okay. If the carbons are like the groups attached around the carbon are different, then a Walden inversion product is obtained. It means if the chiral center containing R configuration in the substrate will be getting S configuration in the product side, like inversion of configuration takes place. That is what we are saying, umbrella inversion or Walden inversion, okay. Yeah. So let us look into a few more things. Yeah. So alkyl halides, see one more thing. Yeah. So these are elimination reactions, substitution reactions are there. So when alkyl halides are there, so when these treated with aqueous KOH or aqueous like KOH, NaOH, it will be generally following SN1 substitution reactions. What I am saying, substitution reaction, either SN1 or SN2 depending upon the alkyl groups, alkyl halide groups. If it is primary alkyl halide, so mostly we will be going with the reaction will be taking place with SN2 mechanism. So just remove this chlorine and replace with this OH group. Yes, that's it. Okay, this is what happens in the SN2 reaction. Okay. Now if it is tertiary, halide, okay, same aqueous KOH is given. So now also just remove this chlorine and replace with OH here, but the mechanism followed here is SN2, here it is SN1, okay. So it means in SN1 reaction we will be having a carbocation intermediate, okay, and in SN2 reaction there is no intermediate, directly product formation. SN2 reaction is single step reaction, I am saying. What is that? Single step. SN1 is two step reaction. What I am saying, multi step, that is what two step reaction, SN1, okay. Intermediate is carbocation, substrate converts into carbocation intermediate, and intermediate nucleophile attacks, forms a final product. That is what the second step in SN1. In SN2 it will be only single step reaction, direct like whatever we discussed in the Williamson synthesis, that's what happens in a single step, okay. Now yeah, so let us move and we will discuss about some previous year questions here, okay. So we have alkyl halide, okay, when we are treating with alcoholic KOH. See here I told you aqueous. In the last discussion, what we discussed here, aqueous KOH. Whenever you are seeing alcoholic, form, alcoholic KOH with some heating, so you can directly get some idea about elimination reaction. What I am saying, elimination reaction. So what happens exactly in elimination reaction? Let us see here. See, whenever you are having alcoholic KOH, so write the structure first. Yeah, so we are having like this. So this hydrogen I can write like this. So this is alpha carbon, this is beta carbon. So alpha beta elimination. This is also we discussed in hydrocarbon chapter, no? Alcoholic KOH, okay, O minus. So this will be abstracting a proton from here. giving this negative charge here and Br minus leaves. Okay, so this is what elimination reaction, and we will be generating like this. Yeah, alkene is obtained. So what is our A here? This is the alkene. Okay, to that HBr is added. So addition of HBr to the alkene, simply HBr means it is Markovnikov rule addition. So when we are adding HBr, what happens? So H plus should be added this carbon, and Br minus here will be getting So what is this? Markovnikov addition. Now when unsymmetrical alkene is there, the negative part of the addendum, like adding molecule, is added to least number of hydrogens containing carbon. Yes, this carbon is containing least number of hydrogen, so there you add this Br minus, negative part of this molecule. Yes, this is a major product. Done. Okay, so we got our B also. After this, again use aqueous KOH. Here this time it is aqueous. So what I told you, aqueous KOH means aqueous KOH, when alcoholic KOH it is elimination, aqueous KOH substitution. Therefore our product will be, that's it. See, remove Br minus and add this OH minus, means substitution, right? Like Br minus goes out, OH minus comes in, this will be the final product. So which option is correct? Propane 2-ol is the answer. I hope it is clear. Okay, see, this is previous year question, very simple, right? Okay, next, see, again unsymmetrical alkene, to that HBr should be added, but in presence of peracid. What I told you, in presence of peracid, anti-Markovnikov addition takes place. That's it. With this statement you can directly answer. Okay, so what is anti-Markovnikov rule? The negative part of the addendum is added to more number of hydrogen containing carbon. That's it. So where do we have more number of hydrogen atoms on this? So this carbon is having more number of hydrogen. It is having 2 and this is having 1. So here it is more now. Add Br minus to that carbon. That's it. That will be our product. H should be here. So what is our product? CH3, CH3, CH, CH, next CH2. Yeah. So here I told you to add Br and here you can add H. That's it. This is what anti-Markovnikov rule addition. Yes, final fourth option is the correct answer for this particular question. I hope it is clear. Next, compound that will undergo SN1 reaction with fastest rate. So they are saying fastest rate na. So it means what I told you in SN1 reaction. For example, here I told you whenever we have alkyl halide, like 3 degree alkyl halide and 2 degree and 1 degree. So what I am saying, alkyl halides 2 degree, 1 degree, 3 degree we have different types, 3, 2, 1, like this we have. Always remember, whenever 3 degree is there, that will be more reactive towards SN1 than SN, 2 degree, least is 1 degree and least is this methyl halide. Okay, so now why it is so? Because in SN1 reaction I told you intermediate formation taking place. So what is the intermediate form there? Carbocation. So carbocation will be more stable when we have in the tertiary carbocation form. Okay, whenever it is having more alkyl groups or like stabilizing factor like resonance, that will be more stable carbocation. The respect to alkyl halide will be more reactive towards SN1 reaction. See here, now if I remove this, we will be getting a carbocation here. So that carbocation will be stabilized by this pi electrons of this benzene ring by mesomeric effect, right? Okay, so because the respective carbocation is benzylic carbocation, that's why at the beginning of the class I explained you more about repeatedly like we have spoken about what? Benzylic carbocation, allylic carbocation, vinylic carbocation, again aryl carbocations, because those will be the more much needed things which we need to identify during the chemical reaction. See, if we remove this bromine, what we are getting here? Just remove this and see here. When we remove this, we are getting a carbocation here. So what kind of carbocation it is? Benzylic carbocation. That can be stabilized by the resonance of these pi electrons, right? Okay, so that is a stabilizing factor. Therefore, it will readily involve in the SN1 reaction, like substitution reactions, unimolecular substitution. See, alkyl group is also there, so this also further stabilizes the carbocation by hyperconjugation and inductive effect. So this is simply cyclohexane, okay. So it will also involves in the reaction, but not as fast as the case 1, okay. And here this is also cyclohexane with see, this is secondary carbon and here it is primary carbon, okay. Now here see, if I remove this won't react at all because respect to carbocation generated here is highly unstable. And see, bromine will not be a good leaving group here, I told you, because the lone pair electrons of this bromine or halogen may have some resonating effect, or like it will be releasing the electrons into the ring for the conjugation, therefore it will not goes out that easily, right. It's a bad leaving group here, so it will not show the chemical reaction here. So this is the slowest one. So here simply by this explanation you can say first option is the fastest one which is participating in the reaction. Yes, this is clear, but my question is not up to here, so I want to order write them in the order form. So one is more reactive, then next out of this 2 and 3 I am going with 3, because if I remove this bromide ion, so we will be getting a carbocation which is secondary, that will be stabilized by both alkyl groups, right. Okay, now again, yeah, so let us discuss about 2 and 3 once again. Yeah, so after that it is about SN1. So after that here how many alkyl hydrogens are there? 4 alpha hydrogens are there, 4 hyperconjugations are possible. Here if we remove this bromine, so we will be getting a carbocation. Here we are getting a carbocation, here we are getting a carbocation like this, okay. So this carbocation can be rearranged into this manner, so this is what tertiary carbocation, which is more stable than this. So I am going with 2, so 1, 2, 3, 4. So this is the order of the reactivity. I hope it is clear. So how can we do this? So first remove this, so we will be getting CH2 plus here, okay. So that primary carbocation, so this primary carbocation can be stabilized by like carbocation rearrangement, because this hydrogen can be donated from here to here, hydride shift takes place, and we will be getting a tertiary carbocation which is more stable than this secondary carbocation. That's why 1, 2, 3, 4 is a correct order for this reaction, okay. I hope this is also important and it is clear, okay. Next, consider the reaction. For this reaction will be fastest in, yes. See, this is primary alkyl halide now. So for primary alkyl halides always SN1 is favored over SN2 is favored over SN1. See, it will be reverse. So for SN1 I told you 3, 2, 1, 3 degree, 1 degree, 3 degree, 2 degree, 1 degree is the order of the reactivity. For SN2 reactions, for SN2 it is 1 degree, 2 degree and 3 degree reaction. This is the reactivity order, okay. And SN2 reaction is favored in polar aprotic solvents. What is that? Polar aprotic solvents. SN2 is favored in polar aprotic. And when it comes to SN1, it is polar protic. Compound should be, that solvent should be polar in the both case, okay. And if it is protic solvent, so it means it should form hydrogen bonds. If it is protic solvent, that will be favors SN1. If it is aprotic solvent, it means it won't show hydrogen bonding character, that can be considered as aprotic, okay. So that favors SN2 mechanism. So SN2 is favored by polar aprotic. See, here it is ethanol, maybe spelling mistake, and methanol, okay, and water, and here it is DMF, NN dimethyl formaldehyde. So we can write this is the DMF, okay. So it won't form hydrogen bond effectively also, and therefore so this will be polar aprotic solvent, but these 3, 1, 2, 4 are polar protic because they can form hydrogen bonding also effectively then when compared with the third option. So I can say 1, 2, and 4 options will favor SN1 more, and the third option will favors SN2. Okay, so why I am saying this SN1 SN2 favor means, see what kind of alkyl halides they given. It is primary alkyl halides with NaCN, Cn minus. So this is a substitution now. So primary halides involves in SN2 reaction mechanism. Which mechanism? SN2. So this SN2 mechanism favored by polar aprotic solvent. That's it. So that's why third option is correct for this particular question. Okay. Now tell me, identify the Schwartz reaction. Yes, we discussed about Schwartz reaction. See, Schwartz and Finkelstein I told now. So Finkelstein is for alkyl iodides. Okay. Schwartz for alkyl fluorides. Yes, identify alkyl fluorides. Only option 4 is there. Yeah. So what is this? Alkyl fluoride is prepared when we use this COF2. So bromine is replaced, exchanged by this fluorine. So we got this compound. I hope it is clear. Okay, this is what? Schwartz reaction. Okay, next, what about this? See, alkyl bromide with sodium iodide. So this is what? Finkelstein reaction. Finkelstein reaction for alkyl iodide preparation. What about this? See, alkyl iodides when treated with sodium in dry ether gives higher alkanes. This is what? Woods reaction. And what about this? 2 moles of aryl halides, like this is actually phenyl ring. So you can understand this like this. Okay, this one is 2 moles. So let us take them as 2 moles here. Yeah, so this is treated with sodium in dry ether. So just remove this, coupling takes place here, aryl coupling. So it will be also giving a compound like this. Okay, so this is about C. Okay, this is what happening here. Okay, so we can call this reaction as Fittig reaction. What is that? Fittig reaction. So Woods reaction means alkyl iodides, like alkyl halides. Fittig reaction means only aryl halides, like aryl fluoride, like phenyl fluorides, something like phenyl bromides, phenyl chlorides, like that. Okay, now Woods fitting reaction will be there. What I am saying? Woods fitting. It means it is a combination of both reaction. One is alkyl iodide, alkyl halide, another one is aryl halide. So combination of these two called as Woods fitting reaction. Okay. Next, which one of the following does not undergo hydrolysis by SN1? See, I told you in SN1 what is the carbocation, like intermediate formed, carbocation is the intermediate. Okay, if the intermediate formed is more stable carbocation, SN1 reaction favors more, readily reaction takes place. If it is highly unstable, reaction won't takes place or it will not undergo the further. See here, so if we remove this chlorine, we will be getting benzylic carbocation which is stabilized. Okay, so if we remove chlorine here also, we are getting allylic carbocation, that is also stabilized by this conjugation, right? Here also by conjugation. See, if we remove this, we will be getting a tertiary carbocation. Look here. Yeah, this is tertiary carbocation. This is highly stabilized by these 3 alkyl groups by hyperconjugation and inductive effect, right? Okay, so this is also stabilized. Now what about this? So if we remove this, we are getting a carbocation like this. Yeah, so this carbocation is highly unstable. That's why I told you vinyl halides will not involve in this SN type reactions. So you can write a statement, vinyl and aryl halides won't participate in SN type reactions. I hope it is clear. So that's why you can choose which is not undergoing hydrolysis means, so option D will not undergoes hydrolysis. You can choose answer like that. Okay, next. Yeah, so here, yeah, Schwartz reaction, what do we studied in the Schwartz reaction? It is for preparation of what? Schwartz is for preparation of alkyl fluorides. Yes. Finkelstein is for alkyl iodides. Yes. Next, this is done. When it comes to Sandmeyer reaction, this is for aryl halides like this. Okay, so you can choose option B1, yes, B1 here and here, C2, yeah, only option this is there, see A3, yes, only this option is there, so you can go with option number D. I hope it is clear. Sandmeyer reaction is for preparation of alkyl bromides. Okay, so this already I told you, alkene is there, yes, to that HBr should be added, but in presence of peracids like peroxide bond is there. So what we can discuss here, so we know whenever alkene is there with HBr and peracid, it follows anti-Markovnikov rule. So the negative part of this HBr, negative part means Br minus and positive part means H plus. So negative part of this adding molecule will be goes to the more number of hydrogen containing carbon. So here it is having two hydrogens, here only one hydrogen. See, this won't react because this is already highly stable, so don't disturb this, only reaction takes place here. So negative part will goes to the more number of hydrogen containing carbon, and it is giving us BrH, that's it. So yeah, so what they are asking, major product X formed in the given reaction is an example of what? This is an example of primary, yeah. So which kind of carbon it is? Halogen attached carbon is, see, this is attached directly to the one carbon, right? Right, this is what? Only one carbon. I mean, this carbon is surrounded by only one carbon. It means it is primary alkyl halide. So X is B, that's it. Yeah. So in Woods-Fittig reaction, what I told you, when these names are combined, it is a cross coupling. Na? Woods means alkyl halides, Fittig means aryl halides, like this. When it is treated with sodium in dry ether, so what happens? Compound X, see, in Woods-Fittig reaction, a compound X reacts with alkyl halide. So what is X? So I told you Fittig means what? That should be what? That should be aryl groups only, na? So it means aryl halide. So it is not aryl halide, this is not halide, this is not aryl halide, this is aryl chloride, yeah. So our compound X is what? Aryl chloride. So this is what? Aryl chloride. This is what you need to understand here. So what is the product formed here? The product formed in this reaction will be like this. That's it. This is the product. Just remove these two halogens from here using this sodium as NaX. So it will form 2 NaX and giving 1 mole this one when we take this 2 moles. Yes. Yeah. So this is about the session. Yeah. So this is about the session. So tomorrow we will be discussing few more questions. So if you have any confusions or any difficulties in understanding this haloalkanes and haloarenes chapter, so you can write in the comment box. Okay. So you can expect at least 1 or 2 questions from this particular topic. So for all these topics like haloalkanes, haloarenes, and then next when it comes to alcohols, phenols, ethers, carboxylic acids, I mean aldehydes, ketones, carboxylic acids, amines, all these chapters, the basic thing you need to know is GOC. See, I have discussed GOC very in detail. I have explained everything. So if you want, you can go through those things so that you can like solve these questions very easily. That's why I am directly going with the answers with the flow while doing the questions, not including the GOC part here once again, because you need to apply them on your own when it comes to the question solving. So you can take the help of GOC lectures if you want, and you can go through these things. Okay, I hope this will be helpful for your preparation. So you can write in the comment box whatever the topics you are expecting from us, so that will be added in the upcoming lectures. Okay, thank you for watching. Happy learning.